In a single week, DeepSeek flipped the entire AI world on its head. Their new open source model doesn't just read text, it sees it, turning thousands of words into powerful visual snapshots. Overnight, it went viral on GitHub, leaving Google and OpenAI scrambling to catch up. This is the story of how one breakthrough changed everything. In the fast-moving world of artificial intelligence, few moments stop the industry in its tracks. But this week, DeepSeek did just that. Their new open-source model, DeepSeek OCR, isn't just another AI that reads text. It completely redefines how machines understand information. In less than 24 hours after release, it exploded on GitHub, crossing more than 4,000 stars overnight. The reason is simple. DeepSeek's AI can take a long 1,000-word document and shrink it down to 100 visual tokens, keeping nearly all the meaning intact. That's not just impressive, it's revolutionary. Think of it like this. Most AI models still read text line by line, processing massive amounts of words, tokens, and code. That approach is powerful but slow and expensive. DeepSeek flipped the process. Instead of feeding the language model piles of text, it turns the text into images, runs them through a vision encoder, and gives the AI a compact stream of visual tokens. The result? Way less data to process, far faster performance, and surprisingly accurate results. For AI researchers and companies, this is a big deal. DeepSeek claims a single NVIDIA A100 GPU can now handle roughly 200,000 pages per day using this method. That's a pace that could change how data teams work, especially for projects that depend on reading, organizing, or summarizing huge amounts of information. Think about training data sets, document archives, legal records, or compliance files. Where traditional models choke on size and cost, DeepSeek's method keeps moving. The project itself is fully open source, available on Hugging Face and GitHub under the name DeepSeek AI/DeepSeek OCR. It includes ready-to-run code for NVIDIA GPUs, tools for working with PDFs, and optimization tips using their vision language setup. The model has around 3 billion parameters, but it's split into two smart systems. A 380 million parameter encoder converts the text into compact visual form, while a larger mixture of experts language model handles the text generation. What makes it efficient is something called sparse activation, which means not all parameters run at once, only the ones that matter. This keeps computing costs low without cutting performance. And it's not just theory. On benchmark tests like OmniDoc Bench, DeepSeek OCR outperformed some of the best-known systems out there, including Google's DocOCR 2.0 and MinerU 2.0. Google's model typically needs around 256 tokens per page to process text, while DeepSeek does it with about 100 vision tokens. MinerU can need up to 6,000 tokens per page for dense content, but DeepSeek stays below 800 even in complex cases. That's up to 87% fewer tokens, meaning faster processing and smaller costs. DeepSeek also handled some of the hardest test cases, dense PDFs full of equations, diagrams, and mixed layouts. In the FOX benchmark, designed specifically for complex page formats, the model again delivered top results. And the reason is clear. DeepSeek trained on an incredibly diverse dataset. Around 30 million PDF pages were used, covering 100 languages. About 25 million were in Chinese and English, with another 10 million synthetic diagrams, 5 million chemical formulas, and 1 million geometric figures. That's where the magic lies. This mix of real-world and synthetic data taught DeepSeek's model to understand structure, not just letters and words, but shapes, layouts, and symbols. It doesn't just read, it comprehends. Experts across the AI world immediately took notice. Andrej Karpathy, one of the most respected minds in machine learning, praised DeepSeek OCR as a clever hybrid between computer vision and language understanding. He called it a computer vision system pretending to be a language model, and that's exactly what makes it so powerful. By letting the model see text as images first, it avoids all the usual problems that plague normal OCR systems. Things like Unicode errors, formatting glitches, and corrupted characters. Instead of reading messy code, it reads clean visual structure. Bu Singh from New York University shared a similar view, saying this might be the start of a much bigger shift. Instead of treating vision and language as two separate fields, DeepSeek's design merges them into one shared system. Imagine a future where an AI can read a research paper, understand its graphs, and describe them together in one smooth output. That's the direction DeepSeek seems to be heading. Of course, not everyone is convinced. Some American analysts have raised doubts about DeepSeek's cost and efficiency claims, pointing to earlier projects where numbers were slightly overstated. But even with those questions, the core achievement is undeniable. Cutting token usage by 7 to 20 times compared to older systems is a breakthrough that no one can ignore. And when a single GPU can handle 200,000 pages a day, it's not just innovation, it's cost-saving innovation. But the AI revolution this week didn't stop with DeepSeek. Another Chinese company, ShangShu, stunned creators with its brand new video generation model called VidU Q2. If Google's Veo and OpenAI's Sora focus on cinematic quality, ShangShu is betting on consistency and control. The tool lets users upload up to 7 reference images, things like faces, props, or entire scenes, and then blend them with a text prompt to create smooth, realistic video clips. Behind the scenes, ShangShu's rise has been fast. The company only launched in 2023 out of China's Institute for AI Industry Research, yet it's already reached more than 30 million users across 200 countries, generating over 400 million videos. With this latest release, they're clearly aiming at professional studios and content creators who need more than just random clips. They need control, speed, and reliability. VidU Q2 gives them all three. While DeepSeek and ShangShu focused on information and creativity, Google and UC Santa Cruz tackled something far more critical: human health. Their new system, DeepSomatic, reads cancer genomes with a level of precision that feels almost unreal. Instead of reading DNA as letters or raw data, it converts genetic sequences into images, each pixel representing a small portion of DNA. The AI then scans these pictures for mutations, patterns, and tiny changes that could determine how a tumor behaves. This method allows DeepSomatic to spot details that older tools often miss. The smallest insertions, deletions, or single nucleotide changes that can drive deadly diseases. In testing, it performed across multiple DNA sequencing platforms like Illumina, PacBio, and Oxford Nanopore without retraining. That flexibility alone is groundbreaking. The results speak for themselves. DeepSomatic achieved around 90% accuracy for complex mutation detection, while other systems barely reached 80%. Even more remarkable, it discovered several previously unknown genetic variants in pediatric leukemia and brain cancer samples. For doctors, that means faster diagnosis, fewer false negatives, and a better chance to treat cancer early. It also shows a growing trend, turning raw biological data into visual information that machines can interpret better than humans ever could. Just like DeepSeek visualized text, Google is now visualizing DNA. And finally, on a lighter but equally futuristic note, a company named Kohler revealed a smart toilet called Dakota that uses AI to analyze human waste. It tracks hydration, gut health, and early signs of illness, turning one of life's most private routines into a health checkup. So from AIs that read, see, and even analyze what we flush, this week proves one thing: the AI revolution isn't coming, it's already here. Thanks for watching, and if you enjoyed this breakdown, don't forget to like, subscribe, and stay tuned for more stories that reveal how technology is quietly reshaping our world.